Okay, so welcome. This is our last video for the presentation, and in the past few videos that we have gone through, we started our journey by looking at different expressions in terms of relation and the logical expressions, and in the next video or the second video we looked at branch statements, the if else, if, as well as the case statement. And the third video that we presented, we had the loop statements, and we identified that there are two types of loops in Fortran. We have the while loops and the counting loops, and this screen we are showing you some examples of counting loops. So we described this as a counting loop where we don't have a step here, and we are saying let these statements be executed as the I is incremented from 1 to 10 with a step of 1. And because it's a step of 1, positive 1, we don't indicate in most cases. But you can indicate if you want to, as we did here. Because it's a step of 2, we actually indicated. The third element was indicated. So here, we said this one cannot actually print anything. Statement 1 up to n will not be printed at all, because our I is starting at 1, but our step is -1. So it's not going to work out. But if it were in the other way around, for example, it's starting from I equals 10 to I1, then -1, then it will be reducing from 10 all the way up to 1. So these statements will still be executed the same way we executed here 10 times. After that, we went through this as an example on calculating a factorial. It's something that you need to try, you guys. Try to run this program and see what happens, and write the full program. We have just shown you a portion of this one, but make sure you declare factorial somewhere. You declare n somewhere, as we have always been doing, and you ask somebody to enter the number that you want to calculate a factorial of, and that number will be assigned in this variable n. And we also went through the cycle and exit. Of course, we used exit before when we are looking at the while loops. So we are able to use the exit as the criteria that we can end that indefinite loop. But here we are presented with its cousin, which is a cycle. In other languages, of course, the exit is presented as a break statement, while the cycle is presented as a continue statement. So what these two do actually is, for the cycle, it means whenever this statement, for example, here is true and the cycle has been executed, then statements below the cycle will not be executed for the current iteration. So for the current loop, and the next iteration or the next loop will actually execute. So in this case, it means our program is going to print I from 1 up to 5, but it's going to skip 3, because when I is equal to 3, we are saying it should cycle. So it will not print 3 here. It will print 1, 2, 4, and 5, because those 4 iterations, when it comes here, I is actually evaluating to false. And the exit, that one is to end or to jump out of that the loop that is actually currently in. For example, if we have exit here, instead of going into the next one, incrementing I to 4, as is the case with the cycle, the exit will actually stop the program immediately. So it would only execute or print 1 and 2. The moment I reaches 3, then the program or the loop stops immediately. Okay, so the last part that we had, we left in our previous video, is the part of naming loops. So the loops can be named. If you can remember, when we were looking at the case statement, I think there was also naming, which was the, so you can name loops, you can name even the case statements and the other statements, branch statements. So here we're just showing you how you can name a loop, and this is the while loop. So before the do, you can provide a name. It's optional, but you can provide a name followed by a colon. Then you have your do statement or the do keyword. So you can have statements. We can either have this statement as we did before, but this one is for cycling. So you can have a cycle, or you can have an exit as we did before. So what we are trying to mean is you can have a name. So when you are cycling, you can tell that the cycling should go to which one. They are used when we have nested loop. So if you have one loop inside another, using the name, if you want to exit, you can say when this condition is true, our program should exit. By default, when exit is executed, it exits the current nested loop. But if you want it to exit maybe all loops outwards or out of it, you can specify which loop it should exit out of. So we have the names that can be used. We may explain or demonstrate these concepts in our lab sessions or lab videos that we are going to prepare later. Okay, so as a to-do for loop statements, there are a couple of questions that are the programs that I want you to try out. The first one, we are looking at a Fortran program that should be used to calculate and print out the squares of the even integers between 0 and 50, or a program that should evaluate the following equation for the values in the range of -1 up to 3, if we are using 0.1 as a step from one value to the next. And of course, we have so many other examples that you can try out. Make sure you try these things. Make sure you understand them, you are able to implement them in Fortran. That will help you a lot. Try this one as well. It's a good program. Yeah, the whole of this question is one question. It's a good program, just trying to test your skills, coming up with something small. This is a mathematics tutor. We call it math tutor program. It's a game that you can create and be playing in Fortran. Okay, you are required to further read chapter 5 and 6 of Fortran 90 Programming First Edition. These two books I gave you last time, I uploaded them on the Moodle. So you have the link which you can click and download. So make sure you read chapter 5 and chapter 6. Of course, not everything in these chapters will be needed. The slides that I've given you should guide you, should act as a guide, as a guide that should help you to know what to read, where to actually put more emphasis. There are other materials that should be skipped in these two chapters, so use the slides as your reference. But cement your understanding of what we have covered by going through chapter 5 and 6 of Fortran programming, and the chapter 3 and 4 for Fortran for scientists and engineers. So chapter 3 is all about branch statements, the same with chapter 5 in the first one. Chapter 4 is all about the loop statements. Okay, thank you. See you in the next videos for the practical sessions for the same.